Here's the basic info on how to use tangent. In a right triangle, one with 90 degrees as one of its angles, we can always find the tangent of one of the other angles. Here I'm going to call the other angle theta. Size, anywhere from negative infinity to infinity, we can describe tangent of theta by looking at the unit circle. This circle has a radius 1, so it crosses the x and y axes at 1. Here's the angle theta drawn on the unit circle, and you can tell by looking at this angle theta, it's the same as in a picture of a right triangle. If I either draw the vertical line here or here. Those are two similar triangles, so they'll have the same tangent of theta, the same theta. Now, however, I can describe the opposite and the adjacent sides by using the x and y coordinates. I can use the x and y coordinates of the point where that angle, the ray making that angle, crosses the circle. And so tangent theta equals y divided by x. Notice what happens if I decide to use the bigger triangle. Now, the adjacent side is the radius of the circle of length 1. So when I divide by 1, I get exactly what I started with. In other words, tangent of theta is precisely the length of this vertical line. That's the line which is tangent to the circle, hence the name tangent. Now, in a triangle, where theta is the angle, if you happen to know the tangent theta, we'll call it A, then you can work backwards to find out what the angle is. Theta, the angle, is equal to the arctangent of A, or sometimes it's written with the tangent inverse notation. This will always give you a result in a real triangle between 0 and pi over 2, or 90 degrees. In general, if you give any argument to inverse tangent, the result is defined to be in between negative pi over 2 and pi over 2. And here's what the graph of inverse tangent looks like.